Hello students, today we are going to take a new topic, that is power. What is power? You know, the power is the rate of doing work. That means what is work? The work already we have seen. And what is time? That also we know. So that power here we are saying what is power in the sense how much work we are doing in how much time. Try to understand how much work we are doing in how much time. That decides by a physical quantity. That physical quantity we are calling it as a power. So if you go for the definition of the power, you can see on the definition on the board. So the definition of the power you can see here. The power is just we can see the rate of doing work. This is the rate of doing work. This is called as power. If you go for the formula for the power, you can go with the formula here. The formula, what it says, power is equal to work by time. Power is equals to work by time. That means how much work we are doing in how much time. That means the work done in unit time, I can say. In short, work done in unit time. That is called as the power. Now, if you go for the units of power, if you go, let us go with the units. Power, that is work by time, we can say this is joule per second, or this is also called as watt. Joule per second, we are calling it as watt. This is the SI system units. But the practical unit of power, I repeat, the practical unit of power. So what is the practical unit of power? It is HP. HP. Like students, on a motor, if you go for a motor, to buy a motor in the market, we ask how much is what I can say the power of this motor. Means they will say 1.5 HP, 1 HP, 2 HP. Depending on the efficiency, we decide the value of HP. So here HP is also the unit. This is also the unit. So which unit we prefer for solving the questions? The SI unit. And this is the practical unit. I can say this is the practical unit. That is daily life unit. I can say that is HP is the practical unit, but we don't consider this HP for solving the problems. Then what happens if a problem is having a power with some unit like HP? Then we need to convert that HP value into SI system, that is watt. So how to convert this? You should know 1 HP is equals to 746 watt. This relation you have to remember, 1 HP is equals to 746 watt. Now, coming to whether this power is a scalar quantity or a vector quantity. You can see from the formula, you can see from the definition, what this formula says. It is the work done in unit time. That is the rate of doing work. Work is a scalar quantity. Time is a scalar quantity. So therefore, without any doubt, we can say that the power is a scalar quantity. So point I will write here, power is a scalar quantity. Power is a scalar quantity. Hope you have understood what is power. Now we go for the types of powers. Like we have types of velocities: average velocity, instantaneous velocity. Types of speeds: average speed, instantaneous speed. In the same way, we have the powers as types of powers. That is, we have one type is the instantaneous power, other type is the average power. So we go one by one. First, you go with this. Now, students, we go for the types of power. The first type, what we are discussing, is the instantaneous power. So let us see what is an instantaneous power. So power at the particular instant of time, like we have instantaneous velocity. What do you mean by instantaneous velocity? Instantaneous velocity means a velocity at the particular instant of time. At the same time, in the same way, we say instantaneous power as the power at the particular instant of time. Means at the particular instant, what is the power? That is the instantaneous power, and this instantaneous power changes as the time changes. So let us see what is this instantaneous power. Instantaneous power means power at particular instant of time. Now, if you see this power, it is what? Work by time. But pay attention, what is this work? Already we have discussed this work as it is the dot product of force and displacement. I write the same thing, the dot product of force and displacement. So work, we can write it as F dot S by T. Now, this force as it is, I'm not disturbing this force as it is, dot. What is this displacement by time? Displacement by time, it is velocity. It is velocity. So instantaneous power, we are getting a formula that is F dot V. P is equals to F dot V. It is something like A dot B. So what the concept we have seen under scalar product, A dot B is AB cos theta. In the same way, F dot V is FV cos theta. So let us take that also. This is the basic and the general formula what we refer. But if we if you want to write in the magnitude form, we can write by taking the help of cos theta. So this we can write FV cos theta. Now the power what we have discussed is an instantaneous power. So therefore what I do, I take PI. I indicates instantaneous, so I am writing it as PI. Instantaneous power is the dot product of force and velocity. Now let us go with what I say, the average power. We are doing average power. Now students, average power. What is this average power? Average power, it's a ratio of total work to total time. That means how much work, the total amount of work done in total time, that gives you the average power. So let us see the formula for average power. Power average is equal to total work by total time. Now let us see what is this total work. If suppose a body is at rest and is started moving with a velocity v. A body is at rest means what is the initial velocity? It is 0. Now it is moving with the velocity v means how much is the kinetic energy? It is half mv square. Why I am reminding all these things? The reason here is this is the work done, and we know according to work energy theorem, work done is equals to change in kinetic energy, that I am writing here. So P average is equals to, it is what work done, that is half mv square minus half mu square. Now exceptionally, like we are considering, it's not always, we are considering that initial velocity of the body is 0, so therefore the kinetic energy will become 0. Now we divide this by time, so what it becomes? Half mv square by t. Half mv square by t. Now let us just simplify it. Pay attention, this is 1 by 2 m as it is. This v, I'm writing it as v into v. That means in vector form I am writing v into v divided by this t. Try to understand this 1 by 2 as it is, m as it is. This is v into v, that is v bar dot v bar. I am writing in the vector form. Now what is this velocity by time? This is velocity and this is time, so I can say the velocity by time, it is what? Acceleration. So I'll write that only. So it is 1 by 2 and this is m, and what is this? Acceleration, and this is v bar. Here just we have to remember velocity by time is acceleration. Now students, you know what is ma? You know what is ma? That is the force is the product of mass and acceleration. So what I do, in place of this I will write force. So therefore P average is equal to, what is this part? This part is force. Force, that is F bar dot V bar, because already we have V and we have by 2. So by 2. Now you can clearly see the difference between the instantaneous power and the average power. Here many students, they do mistake in solving the question. They know what is power, but if they don't know what is instantaneous power and what is average power, they do mistake here. The reason here is the instantaneous power, it is just F dot V, but the average power, it is F dot V by 2. You have to be very careful which type of power is asked, whether it is instantaneous power or whether it is what I can say the average power. I hope you have understood. Now let us go for what is the relationship that exists between the average instantaneous power and the average power. You can see clearly, you can see this clearly, it is just F dot V, and that is what F dot V by 2. So what I do, relation means just I can obtain one relation. What is this relation? You can see that is P average is equals to F dot V. This F dot V is PI, that is instantaneous power by 2. That means average power is always half of the instantaneous power. I hope you have understood what is instantaneous power, what is average power, and what is the relationship that exists between the instantaneous power and the average power. Now, students, we are going to discuss the applications of power, concept, the power. What are the applications? Applications means where we can use the concept of power, or in short, I can say how to apply the concept of power in various situations. How to calculate the power in various situations, that we are going to discuss one by one. So this is the first one, I can say, applications. The first one, suppose there is a gun. Try to understand, there is a gun, and from this gun bullets are fired. Bullets are fired, and the mass of this bullet, if I consider the mass of this bullet, mass of each bullet is m, and the velocity with which these bullets are moving, velocity with which these bullets are moving, suppose it is v. It is v. We consider it is v. Now, how many bullets are fired in how much time? That is also very important. So for that, what I consider, n number of bullets, n bullets are fired in time t. Then what is the power of this gun? I hope you are getting. What is the power of this gun? If the gun is firing bullets of mass m and velocity v, and these bullets are how many? These bullets are, we are considering n bullets are getting fired from the gun in time t, then we can say how much is the power for this gun. So power formula, you know, power basic formula, power is equals to work by time. And this work is done in which form? The bullets are fired. That means the work is done in the form of kinetic energy. Kinetic energy. That is, in place of this work, we can write kinetic energy, because energy is the capacity to do work, and dimensionally we can replace. So therefore, for this work, I do half mv square. Why? Because the bullets are fired. Fired means they are moving. They are moving means which type of energy is associated with that? Kinetic energy. And energy is the capacity to do work. So therefore, I'm writing work as half mv square for one bullet by time is t. And this is for only one bullet. What I have written only for one bullet, but how many bullets are fired in time t? So here I have taken complete time t. So n bullets are there. So here I have to multiply by n. So this is the concept, this is the formula what we need to take when the power of the machine gun is asked, by giving mass of the bullet, velocity of the bullet, number of bullets, and time. Directly you can use this concept. Now come to the next situation, second one. This is the gun. Now, you know a conveyor belt. Conveyor belt. What is this conveyor belt? Already we have seen this conveyor belt. Conveyor belt, it's a belt which carries some gravel, some luggage. Like I have given you the example already, conveyor belt we have at the airport. We keep some luggage on that conveyor belt, and the conveyor belt continuously it will be moving. So if you want to calculate what is the power, extra power required for the extra power required to derive the belt or to move the belt with constant velocity, that we are calculating. See, conveyor belt, this is the drum for this conveyor belt. The conveyor belt is, this conveyor belt will be, it will be moving like this. So this conveyor belt we have to move with the velocity v. And the gravel, you know what is a gravel? It may be like, we can say the luggage is also being fallen on the conveyor belt, or we can say gravel construction material is also falling on this, and this construction material is falling at the rate of dm by dt. dm by dt, that means that much mass is falling on the conveyor belt, that is dm, in how much time, that is dt. So this is dm by dt is the amount of the mass of the gravel which is falling on the conveyor belt, and the conveyor belt has to move with how much velocity, v. So we need to give the power, we need to have the force. So let us see how much force we require, extra force required. How much is the extra force required? So it is what, force is equals to, I have already said you, we have the relation, that is F is equals to ma. It is just an incomplete complete concept of motion. That is what I can say, the second law, Newton's second law. We have seen it, we may take v into dm by dt as force, or F is equals to ma. Two concepts I have given. So this force, I'll take it as v into dm by dt. The reason here is mass is not constant. The mass which is falling on the conveyor belt is not constant. So therefore dm by dt into v, I'm considering it as an extra force required to derive the conveyor belt with a constant velocity v. Now we are studying this topic under the concept of power as one of the applications of power. So how much power is required to derive this belt? So that I'm calculating power, or I can say extra power required. So how much is the extra power required? So power is equals to force into velocity, and this force is how much, you can see clearly the force is here, it is v dm by dt. This is the force, and velocity we have, so this v into v, we can write it as v square dm by dt. So this much power, extra power we require for the belt to move with the constant velocity. So this is one of the situation, this is one of the another situation. Next, let us go for the other one. A pump is there. Just imagine one pump is there, and what is the duty of that pump? That pump, what it is doing is, it is taking the water, some amount of water from a well, and what it is doing, it is just taking that water from a well to a height h, and this is not just taking that water to a height h, it is ejecting that water, it is throwing that water with velocity v. So how is the situation? Let us see. This is a well, and here we are having one pump. This is the pump, you can see this is the pump. This pump is taking the water of, suppose, just mass m, and from the height, from the depth, I can say, not the height, it is a depth of this well. Suppose the depth of this well, I take it as h, and after taking the water from this well, this pump is throwing this water with the velocity v. Now under this situation, if you want to calculate the power, how you are going to calculate power of that pump? So you know the power, the basic concept or the basic definition of power is the rate of doing work. So if you go for this pump, or I'll write power of the pump, power of pump is equals to, we write work by time. Now, if you analyze this situation, what I have drawn on the board, this pump is doing two works. It is not just single work. It is doing two works. First work, what it is doing is, it is taking the water from the ground and it is making the water to reach at certain height. First, it is transferring water from the depth of the well or the level of the well. तो वहां से कहां तक गया बेटा? ऊपर तक गया. That is height h. And it is not holding that water at that height. The pump is throwing the water with some velocity. So here it is doing two works. One is lifting the water, another is throwing the water. So lifting the water के लिए हम consider करेंगे, यहाँ पे हम क्या consider करेंगे? Work W1. Throwing for water, that is ejecting the water, W2 by T. Now, you know, work done when you raise some object through a certain height, that work done is in the form of potential energy. And when you throw anything with certain velocity, it is in motion. So therefore, it is associated with the kinetic energy. Kinetic energy is associated with that, right? So what I do, W1 for lifting the water, I take the formula mgh plus, and for ejecting the water, I take half mv square by t. And from this, we can take m common and we can simplify it. So hope you have understood the concepts what we have, that is an applications of work. So here, if you observe in every situation, whether we can say the firing of the bullet from the gun, whether we are running the conveyor belt, moving the conveyor belt, or we are using the pump to lift the water, in every situation, we have not changed the basic concept of power. Power is the rate of doing work. That is work by time. I hope you have understood the applications. Now, the first problem, what we are going to discuss on the concept of power is on the board. Let us see the question here. A particle is there that is moving with a velocity 5I minus 3J plus 6K meters per second. Under the influence of the constant force, and that constant force is 10I plus 10J plus 20K Newton, we need to calculate the instantaneous power applied to the particle is. It's very simple question if you know the concept of instantaneous power. And here you have to be careful. I have to say you have to be more careful which type of power is asked, whether it is instantaneous power or the average power. It is the clearly said we have to calculate the instantaneous power. So what I do here is instantaneous power, that is Pi, is F dot V. It is just the dot product. We have to calculate the dot product. So let us write first what is F. So F is 10I plus 10J plus 20K dot V. What is the velocity vector? It is 5I minus 3J plus 6K. So we have to calculate just the power, means we have to calculate the dot product for this. So dot product, you know, just we have to multiply the coefficients of I. So it is 10 into 5. Here the coefficient of I is 5. Here the coefficient of I is, here it is 10 and here it is 5. So I have written what? 10 into 5. Then plus, always try to write plus. Then here it is what? J, it is 10. यहाँ पे J कितना है बेटा? minus 3. Then again plus. This is how much? 20. और यहाँ पे है हमारे पास 6. Now what I do, you know, this is how much? 50. And this is plus into minus, minus 30, and plus this is 120. 20 into 6, 120. Now 50 plus 120, that is 170, minus 30, that gives us 140. The 140, the units are mentioned in with force as well as with velocity. So directly we can write it, this many watts are there. I hope you have understood the solution. It's very simple for the students, those who know the concept. Otherwise, what happens, you know, you don't know what is instantaneous power, you don't know what is the average power, you don't know how to calculate power, the problems looks very difficult. I hope you have understood this. Now students, let us go or move with the next problem. What is there on the board? Let us see. देखिए problem अब देखते हैं मैडम. A body is moved along a straight line by a machine delivering a constant power. You can see here the power is constant. The power is constant. That means it's neither increases nor decreases, it remains constant. The distance moved by the body in time t is proportional to. So how much distance is moved in time t, that we need to calculate, and this is considered as the very important question for, or very important model also for competitive level. So a body is there, it is moving along a straight line with a constant power. So we know the formula for power. Power is equals to work by time. This is the basic concept what we have. Now, the power is there, okay. That power is constant. And here the body is moving. So I say the work is done in the form of kinetic energy. The body is not at rest. So we cannot say that the work is like it is due to the potential energy. No, here the work is due to the kinetic energy. So therefore what I do here is, this is the power is equals to work. I'm writing it as the body is moving. So therefore work is done in the form of kinetic energy, and this is time t. Now from this, if you cross multiply it, what we get, let us see. Pt, just I'm cross multiplying this, P into T, Pt is equals to half mv square, half mv square. Now what I am doing, the next step, I am multiplying this, just cross multiplication, 2 into Pt, that gives us 2 Pt, and I am taking this m in the denominator, m, that is equals to v square. Now what is this v square? V square, if I write this side, then it is what, 2 Pt by m. So what is v? V is equals to under root of 2 Pt by m. Now he's not asking us how the velocity is varying. He's asking us how the displacement is varying. You can see the distance moved by the body in time t is proportional to. If suppose the question asks how this v is related to time, then here is the solution. Solution is over, and this question was asked already in the competitive level. So if suppose the velocity is asked, so under root of 2 Pt by m, that solution is over. But the question is somewhat ahead. He is asking us to calculate the distance moved in time t. So what I do, this is the velocity, and we know velocity is the rate of change of displacement, rate of change of displacement. So that only I will take this dx by dt. In place of v, I'm taking dx by dt is equals to, pay attention, 2 is constant. As per the question, power is also a constant, mass is a constant. So therefore what I do, I'll write this part separately, that is 2 p by m, and this is what, root t. That root t, I'm writing it as t power 1 by 2. Root we can write it as 1 by 2. Now just what I have to calculate the distance, so I'm just cross multiplying it, under root of 2 p by m into t power 1 by 2 into dt. Now we need to calculate the distance, so I'm have to integrate on both the sides. So if I integrate, so what I'm getting, this is integration of dx. This is a constant, we cannot integrate it, so we have to keep it outside, that is 2p by m, and integration of t power 1 by 2 dt. T power 1 by 2 dt. So what is the integration of t power 1 by 2? You should know what is the integration for t power n. I am writing here for your understanding. Integration of t power n dt is equals to t power n plus 1 by n plus 1. This is the formula what we need to calculate. What we need to use, integration of t power n is t power n plus 1 by n plus 1. Here you can see the power, here it is 1 by 2. So how to calculate this? Let us see. T power 1 by 2 dt is equal to t power 1 by 2 plus 1 by n value is 1 by 2 plus 1. You can see here clearly the value of n is 1 by 2. So therefore t power 1 by 2 plus 1 divided by This is n. N is 1 by 2 plus 1. So how much is 1 by 2 plus 1? If you take the LCM, you will be getting 3 by 2. You will get it. So it is what? 3 power t power 3 by 2 by 3 by 2, that we have to write here. This is x only under root of 2p by m. And for this part, I can write t power 3 by 2 divided by 3 by 2. Now, students, if the displacement is asked, this is the answer. But he's saying that proportional to, that means 2 is constant, p is constant, m is constant, 3 by 2 is also a constant. That means x, I remove this, all this constant, x is proportional to t power 3 by 2. I hope you have understood the question along with the solution. Now, students, let us move for the next question. So next question is, a body of mass m accelerates uniformly from rest to v1 in time t1. From rest means its initial velocity is 0. That I will write it here. You can see the initial, it is starting from rest. That means initial velocity is 0. Final velocity, we can say it is v1. So v is equals to v1, and time we can see clearly it is t1. The instantaneous power delivered to the body as a function of time t. As a function of time t, how much is the instantaneous power, that we are checking. Again, this is also an important model. So initial velocity is this much, final velocity is this much. So we calculate what is the acceleration. So first of all, we calculate acceleration. For acceleration, we know change in velocity by time. Rate of change of velocity, or we can use the concept v is equals to u plus at. If you simplify, you will be getting v minus u by t. Now, students, what we are doing, this is v is v1 minus u is 0 by t. So therefore, a is equals to v1 by t. This is the acceleration. This is the acceleration, that is v1 by t. And moreover, in the question they have given the v1 in time t1. No, so let us modify this. This I will take here t1, t1, t1. Why I am writing t1, t1? The reason here is they have mentioned clearly the body is changing its velocity from 0 to v1 in time t1. So that's why I have written this is v as v1, u as 0, t as t1. That is, this is t1. So v1 by t1 is the acceleration of this body. But the question asked is not the acceleration. The question asked is the instantaneous power. And we know the instantaneous power. Power that is instantaneous is force into velocity, F dot v. Now, of course, this is, so if you go for the magnitude form, just FV we can say, and cos theta is also there, but theta value is 0 here. So cos 0, it is 1. That's why I'm taking just FV, force into velocity. So what is this force? Force, we can write it as MA, and this we can write it as V. V, velocity V. Now, what is this velocity V? Again, what I do, this, for this to calculate velocity V is equals to U plus AT. So this is V, the body is starting from rest 0. Acceleration, just now we have calculated V1 by T1. This is V1 by T1, and this is V1 by T1 into T. So the velocity, we are getting it as V1 by T1 into T. So this is the velocity. Now just substitute and get the answer. Mass is m only. Acceleration is V1 by T1. This is V1 by T1, and this is velocity, that is velocity is V1 by T1 into T. Now just multiply it. This is m. V1 into V1, it is V1 square by T1 into T1. This is T1 square into T. So this is your instantaneous power. I hope you have understood.